properly size a generator for emergency operations centers, specifically when aiming to power lighting and air conditioning within office buildings. Understanding the electrical system is critical. A 110/223 wire single-phase generator is generally the appropriate choice for direct connection to the building's panel box. Let's break down why. Firstly, a single-phase generator produces alternating current, or AC, that flows in one direction at a time, unlike three-phase power, which involves three separate AC waveforms offset by 120 degrees. The 110/220 volts rating signifies that the generator offers two voltage levels. You have 110 volts available between one hot wire and the neutral wire, and 220 volts available between the two hot wires. This is standard for many residential and light commercial applications. Secondly, the three-wire configuration is crucial. This means the generator has three output terminals, two hot wires, often designated as LON and L2, and one neutral wire. The neutral wire provides a return path for the current and is typically grounded. This configuration allows for both 110 volts and 220 volt circuits to be supplied from the same generator. Now, connecting the generator to the panel box requires careful attention to safety protocols. This is where a transfer switch or interlock kit becomes essential. The purpose of a transfer switch is to isolate the building's electrical system from the utility grid. This prevents backfeeding, a situation where the generator sends power back into the utility lines. Backfeeding is extremely dangerous for utility workers who may be working on those lines, assuming they are de-energized. It can also damage the generator and the building's electrical system. The transfer switch essentially creates a break in the connection between the building and the grid, allowing the generator to safely supply power. Interlock kits achieve a similar purpose by physically preventing the main breaker and the generator breaker from being on at the same time. Once the transfer switch or interlock kit is properly installed, you can proceed with connecting the generator's output wires to the corresponding terminals in a panel box. Typically, the 110 volt circuits within the panel are fed from one of the hot wires, LON or L2, and the neutral wire. Appliances or circuits requiring 220 volts, such as some air conditioning units or electric stoves, are connected to both hot wires, LON and L2. It is imperative to verify the voltage requirements of each circuit you intend to power and connect the wires accordingly. Using a voltmeter to confirm the voltage at each terminal is highly recommended before connecting any loads. A common mistake is attempting to use a three-phase generator in a situation that requires single-phase power. While three-phase generators offer advantages in terms of power capacity and efficiency, they are not directly compatible with standard 110/220 volt single-phase panels without additional equipment such as transformers or phase converters. Attempting to connect a three-phase generator directly to a single-phase panel can result in damage to the generator, the panel, and any connected appliances. Understanding the load requirements is also crucial for selecting the appropriate size generator. The total power consumption of all the lighting, air conditioning, and other equipment you intend to run simultaneously must be calculated. This is typically done by adding up the wattage of each device. The generator's wattage rating should be greater than the total load to ensure it can handle the demand without being overloaded. It's also a good practice to add a safety margin of around 20% to account for starting surges, which occur when motors or other inductive loads are initially turned on. Ignoring starting surges can lead to the generator tripping or failing to start the equipment. For example, let's say you need to power 10 100-watt light bulbs, which would use 1000 watts, and a 1500-watt air conditioner. That would require at least a 2500-watt generator. With a 20% safety margin, you would want a generator rated for at least 3000 watts. Another important consideration is the type of fuel the generator uses. Common options include gasoline, diesel, and propane. Each fuel has its own advantages and disadvantages in terms of cost, availability, and storage requirements. Gasoline generators are generally less expensive to purchase, but gasoline can be more difficult to store safely and has a shorter shelf life than diesel. Diesel generators are more fuel efficient and durable, but tend to be more expensive. Propane generators offer a good balance of cost and convenience, and propane can be stored indefinitely. Choice of fuel will depend on the specific needs and circumstances of the emergency operations center. Regularly maintaining the generator is essential to ensure it is ready to perform when needed. This includes checking the oil level, cleaning or replacing the air filter, and inspecting the spark plugs or fuel injectors. It's also a good practice to run the generator periodically under load to keep the engine lubricated and prevent fuel from going stale. Neglecting maintenance can lead to the generator failing to start or running inefficiently, which can be critical during an emergency. Finally, it is important to be aware of local electrical codes and regulations regarding the installation and use of generators. Many jurisdictions require permits for installing transfer switches or interlock kits and may have restrictions on the type and size of generators that can be used. Consulting with a qualified electrician is recommended to ensure compliance with all applicable codes and regulations. In summary, selecting the correct generator for powering emergency operations centers requires careful consideration of voltage requirements, wiring configurations, safety measures, load calculations, fuel types, and maintenance practices. A 110/223 wire single-phase generator combined with a properly installed transfer switch or interlock kit is generally the appropriate solution for directly connecting to the building's panel box and providing reliable power to lighting, air conditioning, and other essential equipment. Always prioritize safety and consult with qualified professionals to ensure safe and compliant installation. To further elaborate on the technical aspects of generator selection and installation, let's delve into some specific details. Firstly, understanding the concept of neutral grounding is crucial. In a 110/220 volts 3-wire system, the neutral wire is typically grounded at the main electrical panel. This grounding provides a return path for fault currents, which helps to protect against electrical shock and equipment damage. When connecting a generator to the panel, it is important to ensure that the generator's neutral wire is also properly grounded. Some generators have a floating neutral, which means the neutral wire is not connected to ground within the generator. In this case, it is necessary to bond the generator's neutral wire to the grounding electrode system at the building's service entrance. This ensures that the generator's neutral is properly grounded and provides the necessary safety protection. Secondly, let's discuss the different types of transfer switches. There are two main types: manual transfer switches and automatic transfer switches. Manual transfer switches require the operator to manually switch between the utility power and the generator power. This is typically done by flipping a switch or moving a lever. Manual transfer switches are less expensive than automatic transfer switches but require someone to be present to operate them. Automatic transfer switches, on the other hand, automatically switch between the utility power and the generator power when a power outage occurs. This is typically done by sensing the voltage on the utility lines and automatically starting the generator and switching the load to the generator when the voltage drops below a certain level. Automatic transfer switches are more convenient than manual transfer switches but are also more expensive. Thirdly, understanding the different types of loads is important for sizing the generator correctly. Loads can be divided into two categories: resistive loads and inductive loads. Resistive loads are loads that primarily convert electrical energy into heat, such as lighting, heaters, and toasters. Inductive loads are loads that primarily use electrical energy to create a magnetic field, such as motors, transformers, and solenoids. Inductive loads require more power to start than resistive loads due to the magnetic field that needs to be established. This is known as the starting surge or inrush current. When sizing a generator, it is important to take into account the starting surges of all the inductive loads. A general rule of thumb is to multiply the wattage of each inductive load by a factor of 3 to 5 to account for the starting surge. For example, a 1500 watt air conditioner may require up to 7500 watts to start. Failure to account for starting surges can result in the generator being overloaded and tripping or failing to start the equipment. Fourthly, let's discuss the importance of using the correct size wiring when connecting the generator to the panel. The wiring must be sized according to the amperage of the generator and the length of the wire run. Using undersized wiring can result in voltage drop, overheating, and even fire. The National Electrical Code, or NEC, provides tables that specify the minimum wire size for different amperage ratings and wire lengths. For example, NEC Table 310.15/16 specifies the allowable ampacities of insulated conductors. It is important to consult with a qualified electrician to ensure that the wiring is properly sized and installed. Fifthly, let's discuss the importance of using ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect against electrical shock by detecting small imbalances in the current flowing through a circuit. If a GFCI detects an imbalance, it will quickly trip the circuit, preventing a potentially fatal electrical shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. When connecting a generator to a panel, it is important to ensure that all circuits that require GFCI protection are properly protected. This can be done by installing GFCI breakers in the panel or by using GFCI receptacles in the circuits. Sixthly, let's discuss the importance of proper ventilation. Generators produce exhaust fumes that contain carbon monoxide, a deadly gas. It is important to operate the generator in a well-ventilated area to prevent carbon monoxide poisoning. Never operate a generator indoors or in an enclosed space such as a garage or shed. Always position the generator so that the exhaust fumes are directed away from buildings and people. Seventhly, let's discuss the importance of storing fuel safely. Gasoline and propane are flammable liquids and should be stored in approved containers in a well-ventilated area away from heat sources and open flames. Never store fuel inside a building or in an enclosed space. Follow all local regulations regarding the storage of flammable liquids. Eighthly, let's discuss the importance of having a qualified electrician inspect the installation. A qualified electrician can ensure that the generator is properly installed, wired, and grounded. They can also verify that the transfer switch is functioning correctly and that all safety precautions have been taken. Having a qualified electrician inspect the installation can help to prevent electrical hazards and ensure that the generator is operating safely and efficiently. Ninthly, let's discuss the importance of having a generator maintenance plan. A generator maintenance plan should include regular inspections, oil changes, filter replacements, and other preventative maintenance tasks. Following a generator maintenance plan can help to extend the life of the generator and ensure that it is ready to perform when needed. Consult with a qualified generator technician to develop a generator maintenance plan that is tailored to your specific needs. Tenthly, let's discuss the importance of understanding the generator's warranty. The generator's warranty will specify the terms and conditions under which the generator is covered for repairs or replacement. It is important to read the warranty carefully and understand your rights and responsibilities. Keep a copy of the warranty in a safe place and refer to it if you experience any problems with the generator. By understanding these additional technical details, you can make informed decisions about generator selection, installation, and maintenance, and ensure that your emergency operations center has a reliable source of backup power.